Hello, everybody, and welcome to another Mystery Box Function Challenge. It is a Friday, so we're having a special, extra challenging Mystery Box Challenge today. In this purple mystery box, there is some math, and your challenge is to figure out what that math is. You can use the link in the description, pause the video, and put in as many numbers as you like at the top, see how they come out changed at the bottom, and use that information to figure out what's inside the purple box. You ready for this challenge? All right, let's begin. Starting with a 0. See what we get here. 0 gives us 0. We've seen that many times before. Could be almost anything. And 1 gives us 1. Okay, I'm going to refrain from saying this could be a line because this is a super challenging one, right? So probably it's something more complicated. So 2 gives us 1.41. Okay, that's a number I'm recognizing now. So I think I have a hunch about what this is. Let's put in a 3. Actually, if it's what I'm thinking it is, it's maybe not that challenging. I'm going to put in a 4 and predict that this is going to give us a 2. All right, so what does this look like to you so far? To me, maybe you know this too, 2 is the square root of 4. If I put in a 9, I think I'm going to get a 3. Yeah, 3 is the square root of 9. So I think we have the square root function here. And if that's our challenge, we've actually had it before, so maybe not so challenging. If it's just the square root of x, then negative numbers should give us that error, that not a number. So let's put in a negative 1. Oh, okay. So this looks like the square root function, at least on the right, but it allows negative numbers. Let's do a few more negatives. So there's negative 2. Oh, and it looks like we're getting kind of a mirror image of the right-hand side. Let's put in a negative 3. Let's put in a negative 4. It should give us 2 if this is symmetric. Yeah, it gives us a 2. Huh. So it's as if somehow suddenly we can put in negative values into the square root function. What would do this? What would make this kind of a symmetrical square root pattern? Can you think of a way to do that? The only way I can think of, so f of x, in the beginning this looked like the square root of x, but we're allowed for some reason to put in negative numbers, and the square root of a negative number is going to give us an error here, so it can't be that. So what are we actually doing? I think we must be turning it positive before we take the square root. Otherwise, it wouldn't work. And how could we just turn it positive? Well, we could just take the absolute value. Now, if we did that, that would allow us to put in a negative 1, and it would turn it into a positive 1 before it took the square root and give you a 1. So basically, all these numbers would come out the same on this side as on this side. So if I put in, for example, a negative 9, it should just give us a 3 because it turns that into a positive 9 by taking the absolute value and then taking the square root of positive 9. And that should give us 3. And there it is. So I think we've got this one. Let's go ahead and reveal it. Yeah, it's the square root of the absolute value of x. So far these Friday challenges have been composite functions. So a function inside a function, and actually both of them have involved the absolute value so far. Let's go ahead and graph this one. It's kind of a cool looking graph. Last Friday, the graph kind of looked like a bat or a W. This one looks like a seagull or a stylized V, but it's pretty cool looking. Well, how did that go for you? Did you see that this had something to do with the square root function? If you got that far, congratulations, that's fantastic. Did you actually come up with this absolute value under the square root function? If you did, major kudos. That's a pretty good use of your graphing skills and showing your mathematical intuition. So congratulations if you got that. All right, see you next time. Thanks, everybody.